Hello everyone. So in the previous video I have completed all the theory syllabus as well as the numerical problems. Nearly I solved 19 numericals also related to all the topics. So thoroughly understand all the numericals and make a note of it. So definitely it will boost your confidence and it will helpful for your board exams also. So simultaneously we need to concentrate on the KCET and the NEET and JEE levels also. So first try to solve all the numericals from the for the board exam so that you will gain some confidence. So later on, so try to concentrate on KCET level questions so that you will build your confidence and it will boost your memories. And later on, go for NEET as well as JEE mains and JEE advanced questions. Okay. So now, so KCET question. So here the first question is the work done in bringing a unit positive charge from the infinity distance at a point at a distance x from the positive point charge q is w, then the potential phi at that point is. Okay, so here they have the given the option wq by x, w by x and wq. Okay, so here what they are saying, the work done in bringing a unit positive charge. Here they are bringing the unit positive charge. Unit positive charge means so charge value is 1. Okay, from infinity distance to the point at the distance x. Okay, so here they have given the distance at the distance x. Okay, from a positive point charge q. Okay, so charge they have taken as q and q is w. Okay, so here they have given for written as w. Okay, for written is w. Then the potential phi at that point is. Okay, so we need to calculate the potential phi. Okay, so what is the formula for potential in terms of written? So we know that so w is equal v is equal to w divided by q. Okay, so potential is work done by charge. Okay, but here potential they have given as phi. Okay, phi is equal to work done. So work done they have given as w, right? So w and q value and q they have given unit charge, so that's why q value becomes 1. Okay, so here very simple question, it will answer becomes phi is equal to w. Okay, so this is the required answer. Okay, so next question, which of the following statement is correct? Okay, so first question is electrostatic force is a conservative force. Second question, second option, potential of a charge q at a point is the work done per unit charge in bringing a charge from the infinity to any point. And option C is spring force and gravitational force are conservative force. Okay, and option D is all of this. See here, so before understanding the question, so first understand what is the meaning of conservative force. See, conservative forces means, so it is a force which does not depends upon the path followed, it depends upon the final and initial positions or initial and final positions. Okay, so here electrostatic force, see electrostatic force is a conservative force. So why? Because electrostatic force is given by the formula F is equal to 1 by 4 pi epsilon q1 q2 by r square. Okay, so that r, and here the work done, so work done for the electrostatic force is given by w is equal to vb minus va into charge. Okay, so here it depends upon the final potential minus initial potential. Okay, it depends upon the final or initial positions only, so that's why electrostatic force is a conservative force. Okay, so this is actually correct. So next one, so potential of a charge q at that point is the work done per unit charge in bringing a charge from infinity to at any point. So this is also correct only. Okay, so this statement mathematical formula is this only, v is equal to w by q. Okay, so work done in bringing the charge from the infinity to at that point, so it is called potential. Okay, so this is also correct only. So next one, spring force. See, spring force is given by the formula F is equal to minus kx. Okay, Hooke's law. Force is directly proportional to the displacement. Okay, so it is also depends upon the x only. Okay, so initial positions and final positions, so that's why spring force is also conservative force as well as gravitational force. So gravitational force is given by the formula F is equal to g mm divided by r square. So this is also gravitational force is also conservative force only. Okay, so that's why, so here, so all the statements are correct. Okay, so see now next numerical is how much work is required to carry a 6 microcoulomb charge from positive terminal to from negative terminal to positive terminal of 9 volt battery. Okay, so here I need to calculate work done. So work done is equal to question mark So on charge value they have given charge is 6 microcoulomb from negative terminal to positive terminal. Okay, so of 9 volt battery means voltage value they have given 9 volt. Okay, so we know that, so potential in terms of work done is given by V is equal to W divided by Q. Okay, from here I need to calculate W becomes potential into charge, and potential, what is potential value? So 9 into what is charge value? So 6 micro means 10 to the power of minus 6. Okay, here 6 nines are, so 54 into 10 to the power of minus 6 joule. Okay, so this is the answer. Okay, so this is very simple question only. So this is also simple question, but in terms of, we need to calculate the work done in terms of electron volt. Here here they are saying a charge of 2 into 10 power minus 3 coulomb is moved through a potential difference of 10 volts in an electric field. How much work in electron volt is required to move a charge? They are asking. Okay, here, so charge value, what is the charge value they have given? So 2 into 10 to the power of minus 3 coulomb. Okay, is moved through a potential difference. Potential difference means V, so that is, so 10 volts. Okay, in an electric field, how much work is required? Okay, so we need to calculate work done, but in terms of electron volt. Okay, so what is the formula for work done in terms of potential? So W becomes V into Q. Okay, so that is equal to, what is V? 10 into Q is 2 into 10 to the power of minus 3. Okay, so that is equal to 10 to the 20 into 10 to the power of minus 3. Okay, so that is work done. But in order to calculate the work done in terms of electron volt, I need to divide by 1.6 into 10 to the power of minus 19. Okay, so this is the charge on the electron. So here, so W becomes, see here, in order to simplify this one, so I will remove this decimal and put a 0 over there. Okay, so it will become 200 into 10 to the power of minus 3 divided by 16 into 16. Okay, so here minus 19, it will become plus 19. Okay, so here 4 4s are 16, 4 5s are 20. Okay, so remaining 1 0 is there. So W is equal to, here 5 by 4 means 1.25. Okay, you need to remember this one. 5 by 4 means 1.25 into 10 to the power of, here 1 0 is there, 10 to the power of 1, 10 to the power of 1, sorry, this one is 19. So 10 to the power of 1 plus 19 means 20. So 20 minus 3, so it will become 17 joule. Okay, so this is the required solution. So see now, next numerical is, a point charge plus Q moves from the point P to the origin O along the path PQRS in an uniform electric field. UEF means uniform electric field. E, find the work done by the field. Okay, so here they are saying the point charge plus Q moves from the point P to the origin O. Okay, along the path, it is from here, the one charging is moving, that is unit positive charge, from the point P, Q, R, O. They are saying it is moving along the path P, Q, R, O in an uniform electric field. This is uniform electric field. Okay, so find the work done by the field. So here I need to calculate the work done. Okay, so what is the work done formula? See, work done is force into displacement. Okay, so it is dot product, not cross product. Okay, so here I need to calculate displacement as well as the force also. Okay, so what is displacement? See, displacement means it is the shortest distance between the two positions, right? So here which is the shortest positions here? So this is the shortest positions. Okay, so this is point P and the point O. Okay, so displacement, I will write it as RF minus RI. Okay, what is the meaning of RF minus RI means? So position at final minus position at initial. Okay, so this is the formula and definition for the displacement. Final position minus initial position. Okay, so D is equal to, what is final position? Final positions, so is 0. Okay, I will take it as, for the three coordinates 0 comma 0 comma 0 minus initial is, so 2a comma b comma 0. Okay, so D becomes 0 minus 2a means minus 2a into I cap. I means corresponding to x cap, sorry, I is corresponding to x axis, j is corresponding to y axis, and k is corresponding to z axis. Okay, so here 0 minus 2a into I cap plus 0 minus b. Okay, 0 minus b means minus b into j cap, and 0 minus 0 means 0 only. Okay, so this is the displacement value. Okay, So now, so W is equal to, but force value, so force value we don't know, okay. So force value in terms of electric field is given by E is equal to F divided by Q. F becomes E into Q. F becomes E into Q into, so displacement value. What is displacement value? So displacement value is minus 2A into I cap minus B into J cap, okay. So here, so W is equal to, here minus, I will write minus here only. So 2A E Q, okay. So now into I cap, okay. And here, so now, so here they have given F value, okay. But electric field, so what is electric field? Electric field is going in X direction, so that's why I will write it right here as I cap, okay. So now I into I means its value is 1 only, okay. But I into J value is 0, okay. So now required solution is work done is equal to minus 2A into EQ, okay.